Gonna go ahead and get started. Thank you everyone for joining us today for today's BSUG. BSUG lecture series is sponsored by the Idaho Power Company. They sponsor a lot of programs that we do, including Lunch and Learn. So if you're local in the Treasure Valley, please reach out to us and we can schedule to have a lecture to your firm. We bring lunch. If you have any technical design questions or assistance, I got one just this past day on solar heat gain and glazing for an open stairwell south-facing facade. So we can assist you with those. But without further ado, today's lecture is ASHRAE Standard 90.1-2022 Appendix G Performance Rating Method. We have Olivia Brady. She's an energy engineer at Karpman Consulting and an AEE Certified Energy Manager. She specializes in building energy modeling to support design decisions, lead certification, code compliance, incentive program participation, and energy audits. With the recent tax bill or infrastructure bill from the Biden administration, there were significant updates to the incentive program for proving through energy modeling that your building uses less energy than it would have with a different design. So additionally, she conducts technical reviews of energy modeling submittals for incentive programs, including the EPA Energy Star Multifamily New Construction Program, Energize, Connecticut's Energy Conscious Blueprint Program, and New Jersey's Pay for Performance Program. Olivia leads Karpman Consulting's training initiatives and has delivered hundreds of hours of instruction on energy modeling, base code compliance. So we're very lucky to have her here. Olivia, you take it away.
Sure. Thank you so much. And thank you for having me. It's really great to connect with other people who are doing similar work in different parts of the country. I'm located in the Northeast and I do a lot of work in New York, New Jersey, Connecticut, Massachusetts, that area. And so it's great to branch out a little bit. All right, so like you heard, I'm with Karpman Consulting. Karpman Consulting is a woman-owned engineering firm founded in 2005, which specializes in projects related to building science, energy conservation, and energy modeling analysis. Some of our work, we do energy code development and research, where we collaborate with jurisdictions on energy code and energy modeling guidelines. We also do education and training. We have a whole catalog of trainings on energy code and energy modeling. All of our trainings are currently free for attendees, and we have a mix of live webinar-based trainings as well as some on-demand trainings. We also do design and implementation of building energy efficiency programs like the New Jersey Pay for Performance program, and we have a team of energy modelers as well. All right, these are the learning objectives. Describe the evolution of the Appendix G performance rating method and its role in energy code compliance. Compare the Appendix G performance rating method to the energy cost budget method and highlight key differences in application and outcomes. Identify key updates in ASHRAE 90.1 Appendix G from the 2019 to the 2022 version, and evaluate how alternative metrics can influence compliance results. So this presentation won't be a detailed training about how to configure your Appendix G model to meet the requirements of 90.1-2022 Appendix G, but you should leave this session with an understanding of the high-level concepts of Appendix G and the recent changes in the 2022 edition of 90.1. Okay, so I'd like to say a few words about the history of whole building energy modeling, as well as Standard 90.1. So two main factors really contributed to the rise in whole building energy modeling, which include advances in personal computers and energy shortages. Prior to the 1960s and 70s, design engineers mainly used manual calculations to size heating and cooling systems. And with the rise of personal computers, more detailed, more sophisticated analysis became possible. Then with the oil crisis of 1973, it resulted in a steep increase in energy costs and also energy shortages. So in response to that, the first version of ASHRAE Standard 90 was published in 1975, and it was really the first document that restricted HVAC lighting and building envelope designs in the interest of energy conservation. So that the standard for the first time really alerted many design professionals to the energy consequences of their designs. In that first edition, the standard included three compliance options. The first was the prescriptive path, which provided performance criteria for envelope, lighting, HVAC, and water heating systems. And then there's also a performance approach that allowed designers to use any combination of building and equipment characteristics that would use equal or less energy on an annual basis as a design resulting from that basic prescriptive approach. Then under the third alternative, the designs could receive a bonus of up to 50% of the amount of solar or wind generated energy. So even back then, we had a prescriptive path and a performance path. And then modern day Standard 90 is split into two substandards, Standard 90.1, which regulates commercial and multifamily designs, and Standard 90.2 that regulates low-rise residential buildings. And the standard has continuous maintenance, so new editions of the standard are published every 3 years. This is the organization of ASHRAE Standard 90.1, in case you're not familiar with the standard. It includes 13 sections, plus normative appendices and informative appendices. The first section is purpose. The purpose of the standard is to establish the minimum efficiency requirements for buildings other than low-rise residential. Then section 2 describes the scope of the standard. The standard addresses new buildings and their systems, and it also addresses additions and also new systems and components in retrofit projects. The standard does not apply to single-family homes, multifamily buildings of 3 stories or fewer above grade, or manufactured houses. Section 3, I'll fly through some of these. Section 3 is just definitions, abbreviations, and acronyms. Section 4, administration and enforcement. This section describes how the standard applies to projects of different scope, including renovations, additions, and new construction projects. And it also covers the compliance options and documentation that needs to be submitted to code officials when demonstrating compliance with the standard. Then sections 5 through 10 each cover a key building system component. Section 5 is dedicated to envelope, Section 6 dedicated to HVAC, and so forth. Then Section 11 in 90.1-2022 includes additional efficiency requirements. Section 12 includes one of the performance-based compliance options, which is called the energy cost budget method. And then the other whole building performance option is described in normative Appendix G, which is called the performance rating method. And we'll really be focusing on this, this pathway, the performance rating method, in this presentation. Okay, so as I mentioned, compliance with Standard 90.1 can be documented following the prescriptive path or one of the performance paths. So the prescriptive path is essentially a checklist of requirements, and in order to comply with the standard prescriptively, projects must meet each and every prescriptive requirement that applies to it. So there are requirements to building envelope in Section 5, requirements applicable to HVAC systems, and Section 6, requirements for surface water heating, and Section 7, requirements related to electric power systems in Section 8. Section 9 covers lighting. Section 10 covers other equipment such as electric motors, and then additional efficiency requirements in Section 11. So within each of these sections, except for Section 11, there are mandatory provisions and prescriptive provisions. So projects that are following the prescriptive path need to meet both the mandatory and prescriptive requirements. And then projects that follow the performance path, they need to still comply with the mandatory provisions. Those mandatory provisions are found in subsection 4 of each of the key sections of the standard. So for example, mandatory requirements related to HVAC are found in subsection 6.4. And the performance path allows design teams the flexibility to not meet some of the prescriptive provisions of 90.1, as long as the energy savings from other systems and components in the design that exceed prescriptive provisions make up for the penalty associated with the systems and components that are falling below the prescriptive requirements. So this concept is referred to as trade-offs. And the value of trade-offs is established using a whole building energy analysis, where you develop two energy models. The first energy model is the model of the proposed design that reflects the building as it's specified, as it's shown on design documents. And then the second simulation is the reference design, which is a virtual building that is used to evaluate compliance of the proposed design. And both simulations are configured as prescribed in ASHRAE Standard 90.1, either Section 12 or Appendix G, depending on the compliance path that the project is following. And then both simulations are developed using the same simulation tool, the same weather data, the same utility rates, and then that relative energy cost that you get out of the model of these two models. The relative energy cost determines compliance of the project with the standard. And we'll look at more specifically what that's like for the Appendix G pathway. But first, what is energy modeling? It's a virtual representation of a building and its energy use. Modern day simulation tools have three main components. There's a graphical user interface that accepts building description information from the modeler. Then there's the calculation engine that performs the energy analysis. And then you'll have some sort of output interface that shows results of the simulation, usually in a user-friendly format like graphs or tables. And I've included some of the popular tools in the margin of the slide. So Energy Plus, OpenStudio, Trace 3D Plus, Trace 700, eQuest, IES Virtual Environment, Design Builder, and Carrier Hourly Analysis Program are some of the popular ones. All right, so why do projects decide to use the performance path of compliance, either through the energy cost budget method or the performance rating method in 90.1? Well, one of the primary reasons that we see is to demonstrate compliance for projects with high fenestration area. In 90.1, the window to wall ratio is capped at 40% in terms of the prescriptive requirement. So if projects can't meet that, they're exceeding that 40% window to wall ratio, and there's no applicable exceptions, then they'll be forced to pursue the performance path. And then just in general, to make up for systems that are not meeting prescriptive requirements by exceeding requirements for other systems. So if for some reason the project can't meet the prescriptive envelope U values, they might choose to pursue the performance path to make up for it with higher efficiency lighting compared to the prescriptive lighting power densities in 90.1. Then to evaluate building performance in terms of energy costs. So the project team might want to evaluate different design options and understand the impact on future utility bills, and then perform an economic analysis of various options. Well, if the team's already doing this, you're already creating an energy model, then perhaps the performance path is the best option for energy code as well. And then lastly, to document above code compliance. Many programs require energy modeling per Appendix G in order to demonstrate performance for programs like LEED, Energy Star, multifamily new construction, and some utility-based incentive programs require it. The energy cost budget method of 90.1-2022 in Section 12 and the performance rating method in Appendix G, they have a lot in common. So both methods can be used for documenting compliance for new construction projects, alterations, and additions to existing buildings, except for designs with no mechanical systems. With both methods, compliance is established based on the relative annual energy cost of two models. And with both models, the proposed design must reflect the specified systems, components, and controls, and that proposed design needs to meet mandatory requirements of 90.1. No matter what pathway a project follows, they need to meet the mandatory requirements. Then another very important concept that's shared between these two methods is that except where specifically instructed, all building systems and equipment need to be modeled identically between the two models that are being developed, which are the proposed design model and the reference building model. And then operating schedules such as building occupancy hours, thermostat set points, or lighting runtime hours must be modeled based on typical characteristics for the building type and must be identical in both models. Okay, there are also some really significant differences between these two methods. With the performance rating method, configuration of the baseline design, which is what the reference design is called for Appendix G performance rating method. It's the baseline design. So configuration of that baseline design depends on project occupancy type and location, but it's otherwise largely independent of the specified systems and components. Then with the energy cost budget method, the budget design has the same type of systems as the proposed design. The second key difference is the efficiency levels at which the reference design is modeled. With the performance rating method, the baseline design has efficiency levels approximately aligned with requirements in 90.1-2004. So we'll come back to this 90.1-2004 concept shortly. And then with the energy cost budget method, the budget design, which is the reference design for energy cost budget method, that budget design is minimally compliant with prescriptive requirements of 90.1-2022. The two methods also differ in how simulation results of the two models are used to determine compliance. So with the performance rating method, a project complies if the annual energy cost of the proposed design is below the baseline energy cost by a set margin. Recall that baseline has efficiency levels approximately aligned with 90.1-2004, so it can't just be the proposed design can't just be less than that baseline, that 2004 level. It has to beat it by a certain margin. And we'll talk about how that's established in more detail shortly, how that margin's established. And then with the energy cost budget method, a project complies if the annual energy cost of the proposed design does not exceed the energy cost budget. Another important difference is that with the performance rating method, there are more opportunities for performance credit. So for example, projects can get credit for specifying a more efficient HVAC system type, low flow plumbing fixtures, and so forth. But with the energy cost budget method, the opportunities for performance credit or trade-off opportunities are more limited. So for example, there's no credit for energy efficient refrigeration systems, no credit for exterior lighting systems or fan system performance and so forth. And then the last very important difference that I want to mention is that the performance rating method may be used for documenting both minimum code compliance and beyond code performance, whereas the energy cost budget method may be used only to document with minimum code compliance. And so what this means for the performance rating method is if a project documents compliance with, say, the New York Energy Code, and it also participates in LEED, then the same modeling protocol, the same method may be used for both purposes. Okay, so we talked a bit about the history and evolution of 90.1. Now I want to sort of hone in on the performance rating method. And so it was first introduced in 90.1, 2004, as a methodology for quantifying performance of designs that substantially exceed the minimum requirements of the standard. Then in the 2016 edition, the methodology underwent some very significant changes. And the first big change is that that's when the Appendix G baseline was set to efficiency levels required in 90.1, 2004. And those efficiency requirements are now included right within the appendix. And I'm showing excerpts from that on the slide here. So you don't need to get the 2004 edition of 90.1 in order to develop your Appendix G models. And so what I'm showing are excerpts from Appendix G showing the baseline requirements for building envelope as well as for lighting. So, and these requirements are aligned with what was required in the 2004 edition. In addition, the Appendix G baseline became more independent of the proposed design in this 2016 edition, in that the HVAC system types depend on just the building occupancy and climate zone. They no longer depend on the heating fuel source in the proposed design. And then starting with the 2016 edition, the performance rating method can be used for both documenting minimum code compliance and beyond code performance. And some examples of beyond code programs that use the 90.1 Appendix G include LEED for new construction, EPA Energy Star Multifamily New Construction Program, as well as many incentive programs in the Northeast. Okay, so as I just mentioned, the Appendix G baseline is approximately aligned with stringency requirements in 90.1-2004. The 2004 efficiency levels are obviously significantly less stringent than what's required prescriptively by 90.1-2022. So we can't establish compliance just by comparing the proposed design energy costs to the baseline energy cost. In fact, the proposed design energy costs need to must be less than the baseline by a set margin. So in order to establish compliance with Appendix G, what's called the Performance Cost Index is used. And this Performance Cost Index is the ratio of the proposed building energy costs to the baseline building energy costs. And those are energy costs that you're getting out of that energy model that you're creating. And then the performance cost index of a given project is then compared to what's called a performance cost index target. And as long as the performance cost index does not exceed the performance cost index target, then the project meets code requirements. And the graph on the right here illustrates this logic. So the vertical axis shows the performance cost index values. If the proposed design is approximately as efficient as was minimally required by 90.1-2004, then the proposed building energy cost will be approximately equal to the baseline energy cost, and the project will have a PCI of 1. Then if the project is a net zero building, the proposed building energy cost will be approximately equal to 0, and the PCI would be 0. And then when a project is just minimally complying with 90.1-2022, the PCI would be equal to the PCI target. Okay, so what is this PCI target? Well, to calculate the PCI target, the baseline building energy cost, which is the energy cost of the baseline model, it's split into two components. There's the baseline building unregulated energy cost and the baseline building regulated energy cost. The baseline building regulated energy cost is then multiplied by what's called a building performance factor, or BPF, which is a coefficient that's prescribed in Section 4 of 90.1 that relates to the relative stringency of the standard. And also in this PCI target equation, new in 90.1-2022 is a term to account for prescriptive renewables. Then in the denominator, we have the baseline building performance, which is the total energy cost of the baseline model. So it's the sum of the unregulated energy costs and the regulated energy costs of the baseline. And when I say the energy costs, I mean the annual energy cost from the energy model using either actual rates for purchased energy or state average energy prices published by DOE's Energy Information Administration. So I'll cover each of these terms on the following slides. The first term in that PCI target equation is the baseline building unregulated energy costs. So this is the portion of the baseline energy use associated with systems and components that are not regulated by standard 90.1. So these systems do not have any requirements prescribed within 90.1. And some examples include miscellaneous plug loads, such as from kitchen appliances or consumer electronics, or energy use of industrial systems with no requirements in 90.1. And these systems are typically not a trade-off opportunity, and they're modeled the same in the baseline and proposed designs. The second term in this equation that I'll discuss is the baseline building regulated energy costs. So this is the energy costs of the baseline systems and components that are regulated by standard 90.1. Those regulated systems are those included in sections 5 through 10, and they include envelope, lighting, HVAC, surface water heating, and so forth. And those regulated systems are modeled at efficiency levels prescribed in Appendix G in the baseline, which are generally based on the requirements in 90.1-2004. And then in the proposed design, the regulated loads must match the design documents. So as a general rule, the regulated systems can contribute to performance trade-offs with Appendix G. All right, next I'll talk about the building performance factor. So the building performance factor, BPF, this term quantifies the change in stringency between 90.1-2022 versus 90.1-2004. And the building performance factor is a multiplier on the modeled baseline building regulated energy costs. So it effectively estimates what the energy costs associated with systems and components in the baseline that are regulated by 90.1 would have been if they were modeled at efficiency levels equivalent to 90.1-2022. How I like to think about it is this BPF is taking our baseline building regulated energy costs, which is modeled at 2004 levels, and it's bringing it up to 90.1-2022 levels. And for each edition of standard 90.1, the building performance factors are determined by Pacific Northwest National Laboratory, or PNNL, using prototype models. Those prototype models are representative of US building stock. So there are versions of these prototype models for each climate zone and for common building types, such as offices of different sizes, retail, school, healthcare, hotel, warehouse, restaurant, and multifamily. And so there's a version of the prototype for each edition of 90.1, starting with 2004. And the building performance factor for each building type and climate zone is calculated as the ratio of regulated energy costs in that prototype model when it's configured to minimally comply with 90.1-2022 versus that prototype model configured to minimally comply with 90.1-2004. So again, that BPF really is just representing the change in stringency across different editions of 90.1. And this slide just illustrates how to determine building performance factors that need to be used on projects following Appendix G. So the table that you see on the slide here is included in Section 4 of 90.1, and it provides building performance factors for different building area types. There's also a catch-all category of all other. So if a specific building area type is not listed here, then that project would use the all others row. And then we have columns that list all different climate zones. So for example, an office building located in climate zone 5A, the building performance factor would be 0.49. And a multifamily project in climate zone 4A, the BPF is 0.69, and a school located in climate zone 6A, the BPF is 0.46. So those are the building performance factors that would be used in that PCI target equation. And these values represent the general change in stringency for these climate zones and building types. Okay, the last term in that 90.1-2022 PCI target equation is PRE, which is essentially just the associated energy cost savings for an on-site renewable energy system that minimally complies with prescriptive requirements of Section 10.5.1.1. And this term was added in 90.1-2022. All right, so I'll move now into the major updates for 90.1-2022. And I've captured some of these excerpts. It's okay if you can't read all the fine text. I'll describe what these are. So the first one, this is a big one, is the change in how to account. You now have to account for prescriptive renewables in that PCI target equation. We already looked at this. But yeah, just essentially a new term that includes accounting for the new prescriptive renewable energy requirements in the standard. There are new rules for alterations. So now in Appendix G, there's actually a completely new section with completely new modeling rules that was added for minor alterations. And so there's a new section in Appendix G, G 3.1.4 alterations that distinguishes between a major alteration and a minor alteration. And those aren't official terms that 90.1 uses, but I think it's helpful to think about them that way. So to meet 3.1.4a, project has to include 2 of the 3 items that are listed in this section, and they have to do with the retrofit. So they include the replacement of 2 or more HVAC systems that account for 50% of the capacity serving either heating or cooling loads of the alteration area, 50% or more of the luminaires in the alteration area, or 25% or more of the building envelope area of the alteration. So if 2 of those are met, two of those 3 criteria are met, then it's considered a major alteration. And if it doesn't meet 3.1.4a, it's a minor alteration. And in that case, it would need to follow that new section, which is G 3.3. And basically, G 3.3 sets the baseline at minimum requirements in sections 5 through 10 in the standard of 90.1-2022. So it's no longer a 2004 baseline. It's set based on the requirements in the current edition of the standard. And so because of these changes in modeling methodology for baseline alterations, there's some adjustments to the building performance factors for alterations. So I'm also showing that snippet here, but it says for major alterations, which are those alterations that meet G 3.1.4a, the building performance factor is multiplied by 1.05. So it's made to be less stringent. And then all other alterations for these are minor alterations that are following G 3.3. The building performance factors for those are equal to 1. And then there are new rules for accounting for thermal bridging. So what I'm showing here, it says that each linear and point thermal bridge, as identified in section 5.5.5, shall be modeled using either of the following: a separate model of the assembly within the energy simulation, or by adjusting the Clearfield U factor in accordance with section A 10.2. All right, and then the last major update that I'll mention is the addition of the envelope backstop. And so I'm showing this excerpt from the standard on the slide. and projects need to either comply with all Section 5.5 prescriptive building envelope requirements, or they have the option of modeling the building using the building envelope trade-off compliance option. And the requirement for that is that the proposed envelope performance factor cannot exceed the base envelope performance factor by more than 15% for multifamily residential, hotel/motel, and dormitory buildings. And for all other buildings, the limit is 7%. And you would calculate a weighted average limit if you have a mixture of residential and non-residential occupancies. And so a very basic high-level way of thinking about this is that residential buildings can be 15% worse than prescriptive envelope, and all others can be 7% worse than prescriptive. And my understanding is that these limits were established by doing modeling and using a 70% window-to-wall ratio with all other parameters of the building all other parameters of the building envelope set equal to prescriptive requirements, and these were the percentages that resulted. That's how those targets were set. All right, so there's some minor PRM updates in 90.1-2022. Modeling requirements were added for above grade wall solar reflectance and emittance. The proposed infiltration rate to model if testing was not completed was reduced from 0.6 to 0.45, added a baseline allowance for retail display lighting. The baseline HVAC system type selection procedure and rules were improved quite a bit in 90.1-2022. Of course, there are revised building performance factors to reflect the change in stringency with this new addition. The performance curves are now prescribed for chillers, and there's an addition of Appendix I for alternate metrics. And we'll look at this Appendix I a little bit more. So Appendix I is an informative appendix that describes changes to Section 3, Section 4, and Appendix G for using metrics other than energy cost, including site energy, source energy, and carbon emissions. So these are some changes that may be adopted by the rating authority. And Appendix I also has tables for building performance factors for based on site energy, carbon emissions, and source energy, which would replace the cost building performance factors that are in table 4.2.1.1. Okay, so why does that performance metric matter? I'll walk through a few examples. So we know that the performance metric for 90.1 Appendix G is energy cost. So let's look at an example where the energy cost is impacted greatly by the energy/fuel source. So in the first scenario I have here, we have optimized VAV with all gas space heating, and then the second scenario is VRF with VAV DOAS, which has all electric space heating. So in the first option, the optimized VAV, the annual space heating, let me see if I can get a pointer. Here we go. The annual space heating gas energy consumption is approximately 2,700 MMBTUs. Well, let's compare that to the annual electricity space heating energy consumption for the all electric. It's only 544.8 MMBTU. So you would look at this and you would say, great, the VRF has so much less energy consumption. But energy cost is the metric. So let's calculate the cost for heating for each of these options. And I'm using a gas cost of 70 cents per therm, which is a little outdated, but I got this value from EIA rates for New York for commercial buildings. And so if we use this rate, that comes out to an annual space heating energy cost of 18,886. So we'll do the same for our VRF option with all electric. And so I'm again using a EIA average cost for commercial for electricity at 14 cents per kilowatt hour. It's actually a little bit higher now, but this will still illustrate the point, which is that, you know, if we apply this rate, we get $22,986. Wow, the VRF was so much less than our gas VAV when we're looking at it based on site energy, but now there's a complete reversal where actually our gas VAV has a lower energy cost than our all electric VRF. So we can look at this a little more closely. So what we did was we assessed the percent improvement beyond code for these two different options. So we have our VRF and VAV, DOAS, all electric space heating option, and then the optimized VAV, all gas space heating. And what we're doing here is comparing the percent improvement beyond code when looking at these two projects on a whole building level. So we put all the energy consumption into a calculator to see the percent improvement beyond code across different metrics. So in this chart, you can see that this is the percent improvement beyond code for all electric in blue and then all gas in orange. And what you see is that in terms of site energy, the percent improvement beyond code, when you're using site energy as the metric, it's 33% for the all electric option versus only 8% for the all gas option. Now we can also compare using the energy cost metric instead, which is all the way on the right here. And we're using New York EIA rates. So in this case, the all-electric proposed performs 15% beyond code, whereas the gas option performs 18% beyond code. So again, we see this total reversal in that now the electric option is performing worse than the gas option. So this just goes to show that even with a huge reduction in site energy consumption with the all-electric option, because of the differential cost between gas and electricity on a dollar per energy basis, you just don't see the same savings in terms of energy costs that you see with site energy. Right, and I'll look at another example here. So this example is for service water heating. And what I have is I have a baseline. So our baseline for a multifamily building is a gas-fired central storage water heater. And I'm comparing two proposed options. So I have a central electric storage water heater and a central gas condensing water heater. So again, we can look at the annual energy consumption. And for our baseline, 5,383.8 MMBTU. Compared to our proposed options, we have 3,337 MMBTU for the electric and 3,512.6 MMBTU for our gas. So our two proposed options are basically on par with each other when you're looking at it just based on the energy consumption. Well, I did the same thing that we did for space heating, where we applied our energy costs, and what we get is 69,000 approximately for our baseline, and our electric option, 177,949, compared to $45,032 for our gas option. So, ouch, our electric storage water heater, this would really impact the performance of the project if you were to use this electric option and you're following Appendix G where energy cost is your metric. And here is a comparison across metrics, again, in terms of percent improvement beyond code for the examples that we just looked at. So we have electric storage water heater the gas storage water heater, and then I also added in a heat pump water heater for the sake of comparison. And for these examples, again, we're looking on a whole building level. So this includes the energy consumption of all other systems, but they're held constant. The only thing that's changing across these scenarios is the service water heating fuel type, and then the associated energy consumption. And so when we look at this, we see that in terms of energy costs, the electric storage service water heater, it doesn't even meet code. It's at -8% savings. The gas storage water heater is doing very well at 24% savings beyond code. And then the heat pump does decent at 12%. So it still meets code with the heat pump water heater. Then in terms of site energy, again, this is a very different story. The electric storage and the gas are pretty much on par, and the heat pump performs at 50% beyond code. And so the takeaway here is just that with Appendix G, you really need to think about fuel switches and the impact on performance when energy cost is the metric. You can also see that just based on these few examples, there's a reason why different programs are looking at different metrics other than energy cost in order to evaluate projects. Okay, so that is the end of my prepared presentation. I think we can open it up for questions now. Let me see, I'll open up the chat here and yeah.
Olivia, can you go back to the envelope backstop?
Started opening up a poll.
Yeah, we have a poll evaluation for the
Oh,
participants. That's not for you, don't worry.
okay. I thought I accidentally did that. Yes, you said slide, or wait, someone asked for slide 30. Haley, did you?
I asked for, yeah, the envelope backstop.
The envelope backstop, yes.
And I'm wondering if you can just tell me a little bit more about that.
About the envelope backstop.
Yeah.
So the envelope backstop is really just to limit the trade-offs that you can make with your building envelope. So actually, let me go. I added some extra slides and oh, I ended my presentation. Give me 1 second. Here we go. Okay. All right, so this is an old slide and it also refers to New York Stretch 2020, but basically there was a national survey that showed that a majority of projects that are using modeling to comply with energy code, so those are the performance paths, they trade off worse than code envelope for better than code lighting and HVAC. And the issue with that is that your envelope, the envelope's with the building for the life of the building generally. And so when projects are making these big trade-offs and having significantly worse envelope, then a few years down the line, let's say that they traded off really efficient HVAC systems and controls. We'll say 5 years down the line, some of those controls aren't working as intended, or the equipment's getting older, and so you're not realizing the same savings or the same performance that you had originally. But so the flip side is that they don't want to let you run crazy having worse envelope because, like I said, it's with the building for the life of the building. And so what this envelope backstop is it's just making sure that the envelope isn't too significantly worse than code to limit these issues in later years, if that makes sense.
Yeah. Okay. And is that for new construction and then also minor renovations and major renovations?
I'd have to look at exactly how it applies to, let's see. Okay, new buildings. I think this just applies for
For
new
new
buildings.
buildings. Okay. Okay, that's great. Thank you.
Yeah. Okay. And then I saw a question about slide 30. So I'm not sure if you want me to speak on something specific here, but the takeaway really was just that on a site energy basis, you're seeing massive savings for a VRF system, which is all electric, that you don't see when energy cost is the metric. Actually, when energy cost is the metric, then the all gas space heating option is pulling ahead of an all electric option. And generally, your all electric systems are high efficiency. And so when energy cost is the metric, you're not seeing those same levels of savings.
Hi, I have a question, Olivia.
Sure. Yeah, go ahead, Brendan.
Thanks, and thanks for the presentation. There's a lot of good notes I took for this. I'm an energy modeler, and I was wondering what your take is on. There's been a lot of consternation in the community about the Appendix G starting in 2016 and the idea of it being 2004. But there's like so many, I'll say, gotchas or things that aren't really 2004, like the window to wall ratio and the existing build. Like, what's your take on that? Because I think there's an idea in the marketplace that, we're not really trying to push that hard, but when you actually try to achieve the PCI target on a lot of projects, it is very difficult.
Yes, absolutely. I don't know if I have too much of a hot take on it. I think I've accepted that it is what it is, but yeah, definitely. I I will say from a I appreciate that it is a consistent baseline. I like that I have been recently getting more 90.1 2019 projects, and I don't have to rethink how I do my baseline. I like that, across versions, the baseline is staying the same. That has significantly improved our modeling process. We have just a standard process for projects that doesn't have to get updated with the newer editions of um, the standard. Um, yeah, I don't know that I have any hot takes on the things that don't exactly align with the 2004 edition. I'd be interested to hear yours.
Oh, it's just that we get frustrated. And I'm in a group that we hear a lot of pushback. And so like lead V5 has changed some of the building performance factors. And so there's
Yeah.
um, just trying to figure out how to move forward or at least educate our clients um, about what it's actually going to take and that this is pushing us a lot closer to like a net zero-ish building than people think we are at.
Yes. Yes, I completely agree with that. And I agree it's difficult to um we almost don't even try to explain this like performance cost index target, the 2004 baseline, you know, we as the modelers understand it very well. And so, there is a bit of I don't want to say hand waving, but, we'll provide recommendations for our projects and like we understand where those recommendations are coming from. It's not not always like, if you beat prescriptive requirements of 90.1 2019 2022, that doesn't mean that your building is going to, as you know, it doesn't mean that your building is going to pass. And so we'll have some like kind of like stretch goals, high performance recommendations that push beyond the prescriptive requirements in the standard. Yeah.
Thank you.
Hey, Olivia. First of all, great presentation. Can you open the slide where you were talking about renewable energy, PRE? You were subtracting something from PRE. So
Was
with
it this one
that,
here?
yeah, so with that, we are making it more stringent to meet via performance path. Because if your numerator is going down, your PCI target will be lower.
That is correct, yes. And this is because there are new prescriptive requirements for renewable energy in the standard, and so yeah, correct. It's making it more stringent, and so projects should need to have renewables or I guess get penalized for not having.
Yeah. Will you be sharing the presentation with the group?
Oh, yes. Can you?
No, I mean I can see it on my screen, but will you
Oh,
be sharing the
share the
soft copy?
slides?
Yeah.
Yes, I'm not
That's
sure
entirely
now.
up to you, Olivia, if you want to share the actual slides.
Sure, yeah, I can send the slides, and then they can
Okay.
get
Thank you.
sent out.
Shimei has a question. Could you please talk about when to use PRM versus ECB?
Yeah, so let me go back to this slide. So it depends on the use case. So the energy cost budget method can be used to document minimum code compliance. And so whereas the performance rating method can be used to document both minimum code compliance and beyond code performance. You'll also want to pay attention to, I guess, this line, this fourth line here, that the performance rating method has more opportunities for performance credit, whereas you're more limited with the energy cost budget method. You know, the energy cost budget method, your HVAC system types are they're the same, so you just need to, hopefully your proposed design is exceeding the prescriptive requirements for HVAC system types by some amount, and your energy cost budget is modeled as prescriptively as minimally compliant with 90.1 2022 in sections 5 through 10. And so yeah, I guess it just depends on the project and what you're doing with your design. If you need to get credit for more systems, then maybe go for the performance rating method.
And we have one last question. Can any of the metrics, site energy, source energy metric, GHG, or cost be used to confirm compliance in Appendix G?
So Appendix G is just energy cost, but this informative Appendix I, it's kind of like it's an informative appendix, so it's not like a required portion of the standard. This is just like a kind of by the way, if your authority having jurisdiction wants to adopt anything from Appendix I, this is sort of like a toolkit to do so, where they could then use site energy, source energy, or carbon emissions. But in just Appendix G, energy cost is the metric.
I had a question.
Yeah, go ahead.
Regarding Karpman Consulting, are you guys all energy modelers? Is that what the predominant occupation is? Or you've got some educators too? You were mentioning trainings. I was just curious how you're organized and what your business model is.
Yeah, so a mix of everything. I would say we're all energy modelers. Some of us do more like training and energy code implementation, code like program support for incentive programs and stuff like that. But we're all at the core energy modelers with experience doing Appendix G models, Section 11 models, and energy project consulting.
Thank you.
Sure.
Any other questions? Speak now, forever hold your peace. A copy of the lecture will be available on our YouTube channel, and when I get the slides, I'll include a link in the description of the video so that you can download them.